Welcome back. In this submodule, we're going to go into more detail about functions. We're going to talk about different techniques that you can use to efficiently plot functions. We'll start with notions of symmetry, then we'll move on to notions of transformations, before finally talking about one of my favorite mathematical subjects, which is the notion of inverse function. Now, in particular, we'll get to ways of determining if there's a way of finding out if a function has an inverse or not. Right? We'll develop a technique that will help us determine this. Okay, so to understand what we mean by plotting a function, what I mean is that when we have a relationship like f of x equals something, it's interesting to understand how the output, which is f of x, depends on the input, x. One way to do this is to plot the values of f of x against the inputs x. Okay, so in this sense, what we do is we take the Cartesian pairs x comma f of x and plot these in the plane. Okay, this is somehow easier said than done. You need to know a lot about the function f to be able to do this. If I just give you sort of a randomly chosen function, you might not have much success with this. That's why it's more helpful than to just plot individual points. What we do is we try to get some principles. We try to have certain mental pictures of famous functions and then understand how modifying them changes it. So instead of trying to start from scratch every time, you use these basic principles to guide your sketches. Okay? What I'd like to start with is a notion of symmetry. Okay, right? So we'll start with this idea of even symmetry or symmetric about the y-axis. So the picture for this is that your function looks like a mirror image. It looks like a thing and then its mirror image. Now, what we mean here by symmetry about the y-axis is simply that the reflection is about the y-axis. That it looks like there's a mirror where the y-axis should be, and things are the same on both sides. How do we represent this mathematically? We represent it with this condition here, that f of x is equal to f of minus x. That is, when I take the value 2 and I look at its output, it's the same as if I took the input as negative 2, that these have the same outputs. So I've just displayed two sort of standard examples of this. Here we have the parabola f of x equals x squared minus 4. So this is even. And then I have a fourth order polynomial, x to the fourth plus x squared plus 3. And this is a little bit more subtle shape, but it's also even. A different type of symmetry is what's called odd symmetry, or symmetry about the origin. Right, so here what I do is I take my inputs and I ask the question, if when I put a negative sign on my input, does it come out of the function or not? Right, so to write this again, we say that f of minus x is equal to minus f of x. Right, this is what it means to be have odd symmetry. The reason we call this reflection about the origin is essentially it's a double reflection. First, I reflect over the y-axis, then over the x-axis. So looking at the plots I have here, which I claim are odd, take, for example, this branch here, this one. First, I reflect it over the y-axis, so 1, and then 2, I reflect it over the x-axis. That's what it looks like to have odd symmetry. When you reflect it both times, do you recover the branch on the other side? So let's look at this one. First, I reflect over the y-axis, and then over the x-axis. And I get the same picture. So it has sort of this twofold symmetry. We're first over the y, then over the x. Okay? Now, a kind of natural question to ask here is, why haven't I just discussed having symmetry given by reflection over the x-axis? That is, why did I have reflection over the y-axis as one type of symmetry, and then this double reflection as the other type? Well, I claim that if you were to have this type of symmetry over the x-axis, you wouldn't be a function because you would fail the vertical line test. So it's sort of worth thinking about why we didn't discuss that. Okay? So let's look at a few kind of nice CLEP type questions where I show you some plots and then we just ask the questions, are these even or odd? I don't necessarily need to give you the formula. One can give the formula and check whether, of course, the following holds. If f of minus x is equal to f of x for every x, or if f of minus x equals minus f of x for every x. But I can also show you pictures. So let's start with a picture. So, forgiving my poor handwriting, does this look like it's even, odd, or neither? Well, does it look like a mirror image? Yes, I claim it looks like a mirror image over the y-axis. So this would make it even. Let's look at a numerical example. How about f of x equals 4 minus x squared? We could plot this, of course, but let's just check if it's even or odd. So I ask f of minus x, what's this equal to? 4 minus x squared. So 4 minus x squared, which is equal to f of x. So this implies that it's even. Now, why would I care about this in the context of plotting? Well, if I know that the function is even, then I have some idea of what it should look like. It should look like a mirror image of something. So I can use this as a tool for plotting. So I can use the fact that it's even as a tool for plotting. Let's look at another example. F of x equals x cubed plus x. So this is a degree 3 polynomial. And we can check if it's even or odd. Plug in minus x. So what is minus x cubed? Well, it's actually minus x on the minus on the outside, x quantity cubed. And then this is just minus x. Okay, so just as a remark, minus x quantity cubed is this, right? The minus sign gets multiplied 3 times. The first 2 cancel, and then I'm left with just 1 negative sign. Okay? And now I'll factor out a negative from all of it and just get to this. So I have a negative sign out of the whole thing here, times x cubed plus x. So this is minus f of x. So this tells me my function is odd. So again, I can use this as a tool for plotting. If I know the function's odd, it's going to have this sort of symmetry about the origin, or this sort of double reflection symmetry. So let's try and get a sketch going here. We'll make a little table. When x is 0, f of x is 0. When x is 1, f of x is 2. So maybe our sketch is something like this. And now I use the fact that I have odd symmetry. So perhaps it looks approximately like this. I plot a few points on one branch of the function, and then I use the symmetry properties to fill out the picture. So in general, one can ask questions about, is this function even or odd by just evaluating f of minus x and seeing what pops out. But then this can also be used as a tool to plot functions efficiently.